guys, happy Monday. As promised, I have the rest of the notes here for you from 4.2, which we started on Friday. You're going to want to have your graphing calculator out because this last page of notes are all calculator active questions. So I'll be switching back and forth between the notes and the graphing calculator view so that hopefully you can follow along with some of the sequencing things. So as a reminder, on Friday, we were talking about position and velocity and acceleration and those types of functions again, and using the derivative of position to get velocity and the derivative of velocity to get acceleration. So we're just going to start here with example 4. This is a really graphing calculator heavy question, and it says, an object moves along the x-axis for time 0 to 6 seconds, I'm going to assume. The velocity of the object at time t is given by that function, v of t equals the natural log of t minus 0.15 t cubed plus t squared plus 2t raised to the 4/5 power. So that's kind of a gnarly function that we're going to have to work with, which is why it's a calculator question, because differentiating that by hand, not even once but twice, would be super obnoxious. But A says for t equals 4 is the object speeding up or slowing down. Now remember, in order to tell if something is speeding up or slowing down, we need to compare the signs, the positivity or negativity of the velocity and the acceleration. If they have the same signs, if they're both positive or both negative, then that means the object is speeding up. But if they have opposite signs, meaning one's positive and one's negative, at t equals 4, then that would mean that the object is slowing down. So the first thing I'm going to do is I'm going to get this function typed into the y1 on my graphing calculator. So I'm going to go in here, and it was natural log of x, close my parenthesis, minus 0.15 x to the third, I think, yeah. Plus x squared plus 2x raised to the 4/5 power. And then push enter. Now, that is the velocity function. We are going to need the acceleration function. So that would be the derivative of this function. So to get that, the derivative function or the acceleration function into y2, I'm going to go to that shortcut panel where the nderiv feature is. So alpha window, and nderiv is option 3. Or you can use math, and I think it's number 8. So this is going to be d over dx. Now, if I want to differentiate the function from y1, instead of retyping that whole function, I'm just going to use the alpha trace shortcut and say for the derivative of function y1. And if you just put in at x equals x, then it will give the derivative for the entire function versus just putting in like at x equals a certain number. So now that I have those both stored in there, what we want is the velocity and the acceleration at t equals 4. So I want y1 at 4, and I also want, now y2 is the derivative function, so the acceleration function at t equals 4. And you can see here that we get 2 different signs. So the velocity at t equals 4 was positive, the acceleration at t equals 4 is negative. So that's going to tell me that the particle, or the object in this case, is slowing down. So since v of 4 equals positive 4.497 and a of 4 equals negative 2.713. Yeah, opposite sign. So as v equals 4, the object is slowing down. Okay. Now, B says, at what time on the interval 0 to 6 does the particle change direction? So, since direction is given to us by velocity, positive velocity means it's going in a positive direction, negative velocity means it's going in a negative direction. It changes directions then when the velocity changes from positive to negative or negative to positive, which means when it's 0. So we need to figure out when velocity is 0. So a couple different ways you can do that. I'm going to, again, use the graphing calculator. And since the velocity function is the y1, I'm going to graph that. So I'm going to actually highlight the equal sign for the second function, the acceleration function, because I'm not really interested in seeing that one. I really just want to see the velocity function. And I'm going to graph it. And I see that I have the graph here. Now, it did say on the time interval 0 to 6, so I'm going to quickly change my window to be from 0 to 6 on the x-axis. And it appears that between 0 and 6, the velocity is 0, meaning crosses the x-axis twice. So what we're going to do here is go to second, calculate the 0. Now it's asking for the left bound. You can use your left and right arrows to arrow this thing all the way to the left, or I'm going to straight up say like the left bound is 0 for the first one, because that's clearly to the left. It's between 0 and 1. And I'm just going to type in the right bound is 1. Make a guess. Okay, and it's saying that it's at 0.391. Okay. So t equals 0.391. So since this is just going from 0 to 6, and it looks like it's somewhere right around 5 when I go to do the calculate the 0, instead of arrowing and wasting all the time, I'm literally going to type in 4 is a left bound, 6 is a right bound, push enter. Yeah, it's dang near super close to 5, so 5.008. Remember, you can truncate or round. Now, we can even be more specific and say which direction it's changing from and to which direction. So at t equals 0.391, the velocity goes from below the x-axis to above. Like here it's below, and here it's above. So it's going from left, switching from going left to right. And then at t equals 5, it's going from above to below. So it's going from moving right to moving left. So left to right and then right to left. Okay, cool. That's number 4. All right, number 5. A particle moves along the x-axis so that at any time t is greater than or equal to 0, its velocity is given in meters per second by the function v of t equals 4 plus 2.3 sine of 0.85 t. What is the acceleration of the particle at t equals 4? What does this tell you about the direction of the particle? So what we need to do here, first of all, I noticed that this velocity function is using a trigonometric function in it, so we better make sure our calculator's in radians. And I'm going to go ahead and store this into y1 right away, clear out the ones that are in there. I'm actually going to zoom 6 this back to normal for the next graph, if we have to. And I'll go back to y equals. And clear out these two. And I'm going to store in here 4 plus, actually, better check to make sure I'm in radians. Yeah. 2.3 sine of 0.85x. That's right. Okay. So that's the velocity function. We want the acceleration. So of course we want the derivative of this function. So I'm going to go alpha window and deriv of y1, d over dx of y1 at x equals x. Okay. So since I want the acceleration at 4, that's y2, so I'm going to go y2 at 4. And I get negative 1.89. So the acceleration at 4 is negative 1.890. And we could say that's feet per, actually it's not, it's meters, isn't it? Shoot. Okay. So, where's the erase? Here. Meters per second squared. Now, it says, what is the acceleration of the particle at t equals 4? Okay, we got that. What does this tell you about the direction? So direction is actually given to us by velocity. So I'm also now going to get the velocity at t equals 4. And that is what we stored in for y1. So I'm just going to go alpha trace y1 at 4. And we get 3.412. Okay. So 3.412 meters per second. So since velocity of 4 is positive, the particle is moving Okay. Number 6. An object moves along a line at a time t between 0 and pi. Its position function is given by s of t equals negative 3 sine of 0.25 t squared plus 1. What is the velocity of the object when its acceleration is 0? Okay. So first of all, we need to figure out when the acceleration is 0. So we're going to want to know when the acceleration graph crosses the x-axis between 0 and pi. So this is going to be interesting because we have the position function and the acceleration then is the second derivative. So we're going to go to y equals, clear out the 2 that we have in there. Should still be in radians. And so let's put in this function, negative 3 sine of 0.25 x squared plus 1. So that's position. So next would be velocity. So I'm going to get the derivative. D over dx of y1 and x equals x. Now, if I want the acceleration function, I want the derivative of the velocity function. So now I'm going to go alpha window, 3 is n deriv, d over dx, and I want the derivative now of y2 at x equals x. So y1 is position, y2 is velocity, y3 is acceleration. So we want to know when the acceleration is 0. So what I'm going to do is I'm going to graph just the acceleration function. So I'm going to turn off y2 and y1. If you can't turn them off and they all graph, then make sure you're just looking at the right color. And I'm going to change this color just so I can distinguish it between magenta. Let's go with green. Okay. So I'm going to graph just y3. And now initially when this graphs, it's going to be from -10 to 10. And it's a really, really crazy looking graph. So we're going to change our window because it said this is for times between 0 and pi. So, oh, this is going to take forever. I should have changed my window right off the bat. Okay, we'll just let this go for a minute. Okay, this is graph now, so I'm going to just push window, 0 to pi. And I'm going to regraph. So again, this is the acceleration graph. We want to know when the acceleration is 0. Hopefully it's only once between 0 and pi. And it is moving so slow. But it's moving up, so it's going to cross. I'm sure of it. Okay. We'll let this finish. Looks like it's somewhere, obviously, between 1 and 2. Because I left my scale going by ones. Alright, so second, calculate 0. Again, I'm just going to type in, well, this one wouldn't be too bad, just to shift left and right. There's left. There's right. Oh no. Come on. And make a guess. And we're getting at 1.6165034. And I'm actually going to take that whole number because we're going to need that. And I don't want to round too early. So on the interval 0 to pi, acceleration equals 0 when t equals 1 point, and it was 6165034. So we want to know what the velocity at this time is. So velocity at 1.616 ... is, now I'm going to go back to the calculator and remember that in y1 we have the position function and y2 is the velocity function. So if I just go to my regular screen, I want y2 at 1.6165034 And we get negative 1.925. Negative 1.9, what did I say, 25? Yeah. So it says describe the behavior of the object. Since the velocity is negative, the object is moving left. Cool. Okay. That's for number 6. And last problem, number 7. Says a particle moves along the x-axis so that at a time t between 0 and 15, the velocity of the particle is given by v equals the tangent of the cubic root of t minus 0.2t. Find the time t when the acceleration is 0. So we're going to do that the same way we just did. What does this mean about the velocity? Okay, so we're going to go to our calculator, clear out what we've got here. Now the function they're giving us is the velocity function. So tangent of, now cubic root is under the math, option 4 of x, move out of the radical, minus 0.2 x. Okay, so that is the velocity function. We want the acceleration function, so that'll be the derivative. So alpha window and deriv d over dx of y1 and x equals x. Okay, so first of all, we want to know when the acceleration is 0. So again, we're going to graph just the acceleration, see where it crosses the x-axis. So I unhighlighted. Now I'm going to have to change my window to 0 to 15 because right now it's 0 to pi still. Should have done that first. Okay, I'm going to change my window from 0 to 15. Graph. So it looks like it crosses the x-axis there somewhere between 1 and 3, right around 2. So we will calculate the exact time here when this finishes graphing. All right, so second, calculate 0. I'm going to manually type in 1 for the left bound, 3 for the right bound, enter for a guess, and I get 2.1516. Okay. Acceleration equals 0 when t is approximately 2.1516. It says, what does this mean about the velocity at this instant? So when the acceleration is 0, velocity is not changing. It's constant. So since acceleration is 0 at this time, velocity is not changing. B says at time equals 6, what is the velocity and acceleration? Is the particle speeding up or slowing down? Okay. So v of 6 and a of 6. So just to remind myself here, in y equals, we do have velocity is y1 and acceleration is y2. Okay, so we'll close out of there. And I'm going to get y1 at 6 positive, y2 at 6 is negative. So since they have opposite signs, the particle is slowing down. So let's write that down. The velocity was 0.709-ish, and the acceleration was negative 0.14, I think it was 8 or 9. So rounded, it would be 149. Truncated, it would be 148. Doesn't matter. 149. So it's slowing down since they have opposite signs, or since one's positive and one's negative. Okay. So that's it for 2.4 then. The rest of the time here, I know that video got a little lengthy, sorry about that. The rest of the time you can use to finish working on the assignment for this section, and then on Wednesday we'll jump into 4.3. I should hopefully have the hard copy of the notes and the homework and the daily quiz answer keys uploaded to my website, so you can always check there too. All right, see you guys tomorrow.